Good morning, Professor, and everyone present here. I am Akhtar Hussain. My student ID is 20266Z61. Today I am going to present my final project title an intelligence background removal and replacement system using GrabCut and morphological operation. The main goal of this project is to automatically separate a foreground subject from an image, replace the original background with a new environment while maintaining smooth boundaries and high visual quality. This project combines image segmentation, image enhancement, and background compositing techniques to create an efficient and practical image editing solution. Before discussing the project, let me briefly introduce digital image processing. Digital image processing, or DIP, is the field of using computer algorithm to analyze, modify, and improve digital image. In modern application, image processing plays a crucial role in photography, video, conference, social media, content creation, and computer vision system. This project mainly focuses on two important areas. First, image segmentation, which separate the foreground object from the background. Second, image enhancement, which improve the quality and visual appearance of the abstract object. By combination this technique, we can generate professional looking image automatically. The project was designed with four primary objects. The first object is foreground segmentation, where the human subject is accurately separate from the background using the GrabCut algorithm. The second object is edge optimization, where morphological operations are applied to remove noise, smooth, extract boundaries. The third object is custom scan integration, which allows the segment foreground to be placed onto different background scenes such as bases or urban environment. Finally, the fourth object is illumination enhancement, where histogram equalization improves image contrast and visual quality. Together, these objects form a complete automated background replacement pipeline. Now, let us look the overall workflow of the system. The process begins by loading the background image and the target background image. Next, all images are resized to ensure dimensional consistency. After processing, the GrabCut algorithm is applied to extract the foreground object. The generate max is the refined using morphological operation to remove impaction. Finally, the cleared the client foreground is blended with the select background to produce the final output image. The entire system was developed using Python, OpenCV, NumPy, and Matplotlib. These tools provide efficient image processing, numerical computation, and visualization capabilities. Here I use my own photos background for background using beaches, and second background use the Busan city. The most important component of this project is the GrabCut segmentation algorithm. GrabCut is a graph-based image segmentation technique that separates foreground and background regions. Initially, a bounding box is drawn around object instance. The algorithm then models color distribution using Gaussian matrix model and iteratively classifies pixel as foreground or background. In this project, the algorithm runs for 5 iterations to improve segmentation accuracy. After completion, a binary mask is generated where foreground pixels are preserved and background pixels are removed. That provide an accurate extraction of the subject from the original image. Although GrabCut produce good segmentation result, the generated marks may still contain small hole, noise, or irrigation hits. To overcome this issue, morphological closing is applied. Morphological closing consists of two sequential operations. First, dilation, which fills small gaps and holes. Second, erosion, which restores the object's original structure while preserving the improved. A 5 cross 5 rectangular canal is used. All the process is repeat twice. As a result, the marks become smooth, cleaner, and more suitable for background replacement. The significantly improve the visual quality of the final image. After obtaining a final marks, the foreground object is merged with new background image. Instead, instead of using computationally expensive pixel by pixel operation, NumPy vectorized processing is used for faster execution. The logic is straightforward. Where the max value is 1, the original foreground pixel is retained. Where the max value is 0, the corresponding background pixel is instead. Using this approach, the same foreground can easily be combined with multiple backgrounds without repeating the segmentation process. This marks system both efficient and scalable. To further to further improve image quality, histogram equalization is applied. Many images suffer from low contrast because pixels instead are concentrated with a narrow range. Histogram equalization redistributes these intensity values across the entire grayscale spectrum. The increased contrast enhances facial detail and improve overall visibility. As a result, the final portrait appeared sharper, clearer, and more visually appealing. This slide presents the experiment result of proposed system. Plan A show uh, the original input image. Plan B demonstrate the background integrate into base environment. Plan C city show the same foreground successfully blended into city background. All images were processed at the resolution of 1600 by 1020 pixel. The result demonstrate effect for ground extraction, smooth edge transition, and minimal visual artifact. This output confirms the reliability and effectiveness of the proposed method. The proposed system offers several important advantages. First, it is require minimal user interaction because only an initial background box in the second the generate marks can be restored reused for multiple background replacement improving efficiently. Third, morphological refinement produce cleaner boundaries and more natural looking output. The system can be applied in various real world scenarios including e-commerce, product photography, passport identification, photo generation, virtual backgrounds for online meeting, mobile photo editing application, digital media and content creation platform. This application highly the practical value of the project. To conclude, this project successfully developed the intelligent background removal and replacement the system using GrabCut, segmentation and morphological operation. The proposed method accurately exact foreground object, refine segmentation marks, replace background, efficient and enhance image quality through histogram equalization. The experiment result demonstrate that the system effective, reliable and suitable for a variety of practical application. Thank you for your attention. I will explain the code. Okay. Now I explain my code. Firstly, install Anaconda or Python in my computer. Open Jupyter Notebook and create a notebook. The same folder. Run the cell. Install Jupyter Notebook. Okay. And then create a new file called background replacement. Copy the script, remove pipe, install line for local use, place my 3 images in the same folder. Then I will write this code. This is my first photo, second photo, third photo. First photo is my, second photo is background basis, third photo is background city. Then I will write this code. This is output. This is extract foreground picture. This is the base background result, and this is the city background result, and this is the final result in my project. This is original photo, and then background first one photo where I background use bases, and this is background 2 where my background is Busan Tower or city. Finally, my presentation is done. Thank you everyone. Thank you so much.